Welcome to this lesson on force. It is for Leaving Cert higher level physics students, and it's the additional material on top of the common ordinary level material on which you may be examined. So on the topic of force, you may be asked to derive Newton's law F equals ma. And again, as with all derivations, you must commit to memory the starting point. And after that, hopefully the rest will follow. So what will be our starting point here? Well, we're going to start with the definition of force. What is force and what does it result in? So when an object experiences a force, its momentum changes, okay, its motion changes, and the rate at which this happens, so how quickly it happens, rate of change of momentum, depends on the size of the force that acts on it. So that's our starting point. The force is proportional to the rate of change of momentum. Okay, now the word rate always refers to time and how quickly the change in question happens. So that's where we'll go next. The force is proportional to the change in momentum over the time taken for that change to occur. Alright, now let's put that into some symbols. The force is proportional to, now the change momentum, we can write that as a final momentum subtract the initial momentum. So finding the difference in a final momentum, so P is for momentum, minus initial momentum, P2 minus P1, all divided by T, which is the time taken for that to happen. Okay, and let's recall how we calculate momentum. P is equal to mv. Okay, so let's use this in substitution. Okay, so we will say F is proportional to the final momentum will be the mass of the object in question by the final velocity, and we had been using letter V for that. Subtract the momentum of that same object, so same m, by the initial velocity, which is u, divided by t. Okay, we'll move to our right now to continue. Alright, so hopefully you're starting to see some familiar things. On that top line, m is a common factor, so let's take that out, and we get v minus u. Okay, and divided by t. Alright, but look what is there, v minus u, so that's the change in velocity over the time taken. Of course, that is acceleration. Alright, so now we can write, we're almost there, F is proportional to ma. So we're almost at the end. The end equation says F equals to ma, but we can't say that right now. What we can say is that F is equal to some constant number, we'll call it k, times ma. Okay, and what about this k? Now, by a convenient definition of the Newton, which is the unit of force, 1 Newton is the force that gives a mass of 1 kilograms, an acceleration of 1 meter per second. Okay, and because of that convenient definition, k is equal to 1. And so we can write F is equal to ma. And now you are finished. Alright, so as with all your other derivations, memorize your starting point, rewind this video and go back through it a few times, look at the steps, take out a blank page and try to reproduce as much as it of it as possible before you look back at the notes again, and repetition will hopefully get you there. Thank you.